We're going to look at the classification of proteins based on chemical nature and solubility. We already know that proteins are made up of amino acids linked together by what type of bonds? Glycosidic bonds, is it? Peptide bonds. Good. Now, we are going to look at these proteins based on the chemical nature and solubility. Now, based on chemical nature and solubility, we have one, simple proteins. Now, when we talk about simple proteins are composed of only the building block. And the building block of protein is what? Amino acids, right? So, simple proteins are made up of only amino acid residues. No other thing. It's just like looking at this building as protein. Because protein is a macromolecule, right? Now, if this building is a protein, then simple protein will be a simple building, will be just blocks laid together, no paint, nothing. Do you understand? So when you hear simple proteins, the first thing that should come to your mind is only amino acid residues linked together by peptide bonds. Do you understand that? Examples of simple proteins are albumin. Albumin is a simple protein. Where can we find albumin? Egg, right? Egg white. Egg white, we call it albumin, is it not? Albumin, globulins, collagens, all these are simple proteins. Why are they simple proteins? Because they are made up of what? Only amino acid, no other addition. Good. The next one is conjugated proteins. Conjugated proteins. Now, when they say these two things are conjugated, what does it mean? You are joining two things together, right? Now, conjugated proteins, in addition to the amino acid that makes up the protein, you are adding a non-protein part. It's just like you're adding a protein and a non-protein together. So if you add a protein, amino acids, and non-protein components joining together, what do you call that? Conjugated proteins. Then it means that this conjugated protein is amino acid plus the non-protein part, right? And we said this non-protein moiety, this non-protein component is called what? Prosthetic what? Prosthetic group. The non-protein component is called the prosthetic group. Prosthetic group. Do we get that? So conjugated protein is amino acid plus prosthetic group. Examples of conjugated proteins are glycoprotein. Now from the word glycoprotein, what is the prosthetic group here? Carbohydrate generally, right? Carbohydrates in addition to protein will give us glycoprotein. So we are conjugating carbohydrates and protein together. Lipoprotein, what's the conjugate here? Lipid, right? So lipid in addition to protein will give us lipoprotein, is it not? Yes, lipid is the prosthetic group here. Any non-protein part of it is called the prosthetic group. The glyco here represents carbohydrate generally. It can stand for glucose, it can stand for glycogen, but it represents carbohydrates generally. Now, phosphoprotein. What is the prosthetic group here? Phosphate. So if you attach phosphate group to protein, you have phosphoprotein. But if you have only amino acid in that protein, what do you call that? Simple protein, right? If you attach a non-protein component, you call that what? Conjugated protein. Now the third group here is a derived protein. Derived means what? Gotten from. Is it not? So derived protein is gotten from the denaturation or degradation of either simple proteins or conjugated proteins. What does that mean? If I have a simple protein and I break down the bonds, the resultant, what I get from that is called what? Derived protein. If I break down glycoprotein, what I get from the glycoprotein is what? Derived protein, right? So derived protein is gotten from either simple or conjugated protein. When we talk about denaturation, do you know that we know that egg is rich in protein, right? Do you know that the protein you get from egg, raw egg, and the one you get from boiled egg and the one you get from fried egg, they are different. As you're boiling your egg, you are denaturing the protein. Heating denatures protein. As you're frying your egg, you are denaturing the protein. That is why, do you know it's best to take egg in the raw state? Before I talk more about that, any question on this? Any question?